Let's look at what is odd. Odd functions are those that are reflected on the origin. So for example, if I have, let's say that is my function on this side, and then if I reflect this through this point, then this is the reflection. If I reflect this through this, then this is the reflection. If I reflect this through this, then this is the reflection. So you get reflected through origin. There is another way you can get the same thing. If you first reflect it across the y-axis, for example, you will get that, right? And then you flip it or reflect it across the x-axis, then you will get here. So this point comes here, sorry, here, this point comes here. So you reflect across both axes. You could go down first maybe, and then come here, you still get the same thing. So if this is A and that is B, if this is A comma B, what is this? This is negative A. What is this? Negative A, negative B. This will be true for all X and Y on this graph. So f of negative X will be what? If X was A, B was f of X, right? If we replace it with negative A, that is f of negative X, what is that? How does this relate to that? See, this one was f of X, and this one is f of negative X. What's the relation between them? They're negative of each other, negative of f of X. When you get this, it's an odd function. Some functions will be odd, some functions will be even, and some functions will be neither. Because not all functions are symmetric, right? If they're symmetric across y-axis, they're even. If they're symmetric across the origin, they're odd. If none of those, then they are neither odd nor even. We looked at cubic earlier, right? Y equals. So if we check this, f of negative x, we saw that earlier. What is this equal to? Negative x cubed. And x cubed was f of x. So this is negative f of x. So f of negative x equals negative f of x. So it is an odd function. And we also saw it was symmetric about the origin. Let's look at tan. So tan 0 is 0 and this, let's say pi over 2. I'm only drawing one period. Okay, so tan is odd, right? You can see it's reflected and then it's repeating. That means tan of negative theta equals negative tan theta. That's good. It's like this, if you reflect will be here, and then if you reflect it will be here. And that's true for all parts. So sine of negative theta is. So let's summarize. Let's check all the trig functions if they are odd or even. So sine of negative theta, cosine of negative theta, and tan of negative theta. And here's cosecant of negative theta and secant of negative theta and cotangent of negative theta. So sine of negative theta is, this is negative sine theta. And cosine of negative theta is cosine theta. And tan of negative theta is negative tan theta. And cosecant negative theta means 1 over sine of negative theta, right? So this is equal to, and we know sine of negative theta is negative sine theta. That means this is 1 over negative sine theta. But 1 over sine is cosecant and there is a minus. So this is negative cosecant theta, right? So this one I kind of showed. What is secant of negative theta? You can look here. Secant theta And cotangent of negative theta is negative cotangent theta. So this is odd. Both of those are odd. Both of these are even. And both of these are odd. If I have to find sine of negative theta plus 2 pi, what do you think that would be? It's sine of, we factor the negative here, theta minus 2 pi, right? So sine of negative of anything is negative sine of that, so which is this. But can we further simplify this? Because you know the periodicity of sine is 2 pi. That means this is just shifting by one period, right? So that would just be negative sine theta. Negative is already there. Sine of theta minus 2 pi is just sine theta, we know, because you can shift it left or right by the period any number of times and it's not going to change. Right? So I'm kind of combining the two concepts of the periodicity and odd and even in this particular example.